In this video, I'll share with you very important points about simple microscope. It is an optical instrument that gives rise to a magnified erect image. Now let us come to the construction of simple microscope. It consists of nothing but a small focal length convex lens having optical center O and two focal points on either side, and this dotted line represents principal axis of this lens. Now let us see how it works to produce a large image of a small object. We place the small object between optical center and the principal focus of the lens. The object is A1 B1. According to refraction of rays of light, a virtual and enlarged erect image A2 B2 is formed between f and 2f of the lens, and this lens produces an erect magnified image A2 B2. And here x is representing distance of object from the optical center of lens, and d represents distance of the final image from the lens. Actually, d is nothing but least distance of distinct vision, so that the image appears distinct and very much clear, precise to the observer whose eye is very close to the lens. Now let us come to magnifying power of a simple microscope. If we place the object as well as the image one by one at distance d from the eye of the observer, then we find that angle alpha is subtended by the object at the eye of observer or at optical center of the lens, and if we place the enlarged image, it subtends angle beta at the same point. The ratio of angle beta to angle alpha represents magnifying power of simple microscope. Now let us modify this to derive a simplified expression for magnifying power. Let us come to the same formula definition: m is equal to beta over alpha. If alpha and beta are very small, then these can be replaced by tan beta and tan alpha. From the previous diagram, we can find value of tan beta and tan alpha and put those values in the formula for magnifying power. Putting the value of tan beta and tan alpha, after simplification we get m equal to d multiplied by 1 upon x. Now let us apply lens formula to the lens used in simple microscope. 1 upon v minus 1 upon u equal to 1 upon x. Putting various values of distance of object from the lens, distance of image from the lens, we get a value for 1 over x equal to 1 over d plus 1 upon x. Putting this value of 1 upon x in previous formula for magnifying power, we get final result m equal to 1 plus d upon x. That's all. Thank you very much.